So if we're given a graph, we want to first look at what those zeros are. So I found one here at -5, another one that's crossing at -1, and then the last one crosses at 3. We could list out what those zeros are. So x equals -5 is one of them, x equals -1, and x equals 3. But we have to consider the multiplicities. This -5 is going up and then it bounces off the axis. That's our clue that we have an even multiplicity. So it is a multiplicity of 2 because it bounces. X equals 1 goes straight through, so it's a multiplicity of 1. But x equals 3 bounces off the axis again, so that's a multiplicity of 2. Now if we take those zeros and turn them into factors, we would add the 5 to the other side to create a factor of x plus 5. But since it's a multiplicity of 2, we make that squared. We'd add 1 to the other side, so now it's equal to 0, so that becomes x plus 1. And it doesn't need to write an exponent of 1, but the x equals 3 becomes x minus 3 with a multiplicity of 2, making a squared on it. So right now that's all we have, but because we have a graph, we have some more information. We know that it has a point that it goes through of 0, 2. Anytime we're given the point, we can then figure out what that a value would be. So if it is 0, 2, that's an x of 0 and a y of 2, I can plug those in and find out the missing value a. So y is 2, I'm going to plug that in here. And then for every x, I'm going to just put in a 0. So that would look like 2 equals a times x plus 5 squared, 0 plus 1, and 0 minus 3 squared. So every single x became a 0. Now we have enough information just to simplify. So that'll be 2 equals a times 0 plus 5 is just 5, so 5 squared. That's 25. 0 plus 1 is just 1. And 0 minus 3 is -3, but -3 squared ends up being 9. And you could have put that in your calculator and just do parentheses 0 plus 5 squared, 0 plus 1, 0 minus 3 squared. You'll end up getting 225, and that's what I would get if I do 25 times 1 times 9. 225. So 2 equals a times 225. But we're solving for a, so I need to undo the multiplication and divide by 225. So we would see if that reduces 2 divided by 225 and keep it in fraction form, but it doesn't. So 2 over 225 is going to be the smallest we can make it. And I put that back into my function. So therefore, we can write this in function notation. P of x is 2 over 225. That's our a value that we found. Now times x plus 5 squared, x plus 1, and x minus 3 squared. All those things are all those factors are multiplied to each other. But we filled in what that specific a value would be. Now this is the only function that could possibly go through those zeros and hit that point 0, 2. All right, so b, I see a 0 at -2, a 0 at +1, and a 0 at +3. I'm just going to write out what those zeros are, and then try to find our multiplicities. So we first identify them, then find the multiplicities. At -2, it bounces, so that's a multiplicity of 2. At 1, what you'll see is it wiggles through the graph. It bends, and it's not going straight through, it bends. So that's a multiplicity of 3. The last one does go straight through. It's not bending, it's not bouncing, it's going straight through that value. So it's a multiplicity of 1. Now let's turn that into our factored form. I'm still going to include the a because I don't know what that vertical stretch or shrink was. And then we can start writing our factor. So if a 0 is x equals -2, I'd add to the other side to get x plus 2. And it has a multiplicity of 2, so that becomes a squared. X minus 1 has a multiplicity of 3. And then x minus 3 has a multiplicity of 1. So I don't have to write an exponent of 1. That usually is implied there. But we do need to solve for a and figure out what is that value that goes in front. In the first example, we saw it was a vertical shrink. So we need to figure out what is going on here. Was it a shrink? Was it a stretch? What happened? We can do that by plugging in a point. Now this point, xy, has a y value of 16. And all the x's are going to be 2's. So I can just plug those in. And it would say 16 equals a times 2 plus 2 squared times 2 minus 1 cubed times 2 minus 3. We work that out a little bit, and you can put all that in your calculator if you want, so I'll do that here. 2 plus 2 squared, 2 minus 1 to the third, and 2 minus 3. We get a -16. Now remember, this is multiplication, so to undo multiplication, we're going to divide. And I get 16 divided by -16 is just -1. So the a value is a -1. So we can say therefore, and p of x, it could be p of x, f of x, g of x, whatever you wanted it to be, equals -1 x plus 2 squared x minus 1 cubed x minus 3. That -1, you can write negative, or you could write an actual -1 there. Either way, there's our polynomial. Our last graph bounces at 1, goes straight through at 3. So I have x equals 1 with a multiplicity of 2, and x equals 3 with a multiplicity of 1. I turn those zeros into the associated factors, so if I subtract 1 to the other side, I get x minus 1. It is squared because it's a multiplicity of 2. And then we do x minus 3 to the first power because it's a multiplicity of 1. If I plug in a point, I know 2, 1, that means that y is 1 and x's are 2. So y equals a times 2 minus 1 squared, 2 minus 3. That would be a times 2 minus 1 is 1 squared. That's just 1, but I'll put it in here for you. You see you get -1 still. Again, it's multiplication, so make sure you're dividing by -1. I get a is -1. So therefore, p of x equals negative x minus 1 squared x minus 3. the last part does it without a graph, but it's still focused on giving you some specific conditions. So it says, write the polynomial with real coefficients that states or satisfies the given conditions. So real coefficients just means that they are going to be a real value and not imaginary. We'll see some imaginary numbers later in module 3, but for this module, we're just doing real coefficients. All right, Q has degree 3 with zeros of 2, -5, and 6. I'm going to write out those zeros. X equals 2, X equals -5, and X equals 6. That allows me to find the factors associated with it. So if I subtract 2, I get X minus 2 equals 0. If I add 5, that means X plus 5 equals 0, so I'm back to 0. And I subtract 6, it's also back to 0. So we found every single factor just by solving that way. So Q of X is A times X minus 2, X plus 5, and X minus 6. If we multiplied this all the way out, this is something that we don't do often, we would have to distribute a ton. But what we would see, and let me do this on a sticky note here for you, is something that would do X times X to give me X squared, and then distribute more here. On the inside, you would get plus 3X minus 10, and then you'd multiply X minus 6. So the X times X is what gave us that X squared. It would then distribute to this part and do X squared times X to give me X cubed. We'd have a lot more distributing, so we'd have a lot of other stuff here in the middle. Eventually we'd get down to -10 times -6, which is positive 60. So there'd be other stuff in the middle, but when we multiplied it out, that first term would be X cubed. The A value is that vertical stretch or shrink that multiplies all the way through. So at the end, I'd have A times X cubed. So when I'm solving for this leading coefficient part, that would lead me to A times X cubed, and we want to have a leading coefficient of -2. So we need this to say -2x cubed. That just means that A is going to end up being -2. So this time they didn't give us a point like they did on the graph, but they gave us some information about the leading coefficient. So Q of X is -2 times X minus 2 times X plus 5 times X minus 3. There's our whole function. B is a little bit trickier because we have fractions and we have some multiplicities. The zeros are 3/4, so X equals 3/4, X equals 1/2, X equals -4, and X equals 3. If we worked backwards, I would have multiplied by 4 to undo the division. So I'm going to multiply by 4, get 4x equals positive 3. And then we'll subtract 3 to the other side, so 4x minus 3 equals 0. I'd multiply by 2 on the 1/2 there, so times 2 makes that 2x equals 1. We'd subtract 1 to the other side so that it has 2x minus 1 equals 0. Add 4 to the other side gives us x plus 4 equals 0. And subtract 3 gives us x minus 3 equals 0. But when we think about the multiplicities, it says that the zeros of 3 and -4 have multiplicities of 2. So this is going to be multiplicity of 2, and this is multiplicity of 2. Now I can put this in factored form. So P of X, A times 4x minus 3, 2x minus 1, x plus 4 squared because of the multiplicity, and x minus 3 squared because of the multiplicity. This time when you start to multiply this all out, it's a little bit trickier. And again, we're not doing the whole thing, but I'm going to be looking at each part of the first terms and the multiplicities. So that would be a 4x times a 2x times an x squared times another x squared. So all of those first terms would lead me to that beginning initial term. So 4x times 2x is 8x squared times another x squared is going to be 8x to the 4th times another x squared is 8x to the 6th. If you were a little bit unsure of how that happened, just do your coefficients, 4 and 2 to get your 8, and then there's 1x, 2x, 3, 4, 5, and 6 x's. So 8x to the 6th is what that would all multiply out to be. So this currently leads to a times 8x to the 6th. And we want a leading coefficient of 16. So if it is a leading coefficient of 16, we have to figure out what do we need to multiply 8 by to get a 16. That a would have to be a 2. So that it would be a 16x to the 6th with that leading coefficient. So I'd write this out, 2 times 4x minus 3 times 2x minus 1, x plus 4 squared, and x minus 3 squared.